You're welcome. All right, so take a look at this problem right here. Let's identify our given information. We know that we have a ball that has a mass of 5 kilograms, is being swung in a circle with a radius of 1.5 meters at a rate of 2 revolutions per second. So the first question is to find the period. And remember that period is the time divided by number of revolutions. And we know that we have 1 second and it goes around twice. So just like the previous problem, our period is 0.5 seconds. Now, because our period is the same, does that mean our tangential velocity is going to be the same? Why not? The radius is different. So this process, it is still 2 pi r over the period. So we have 2 times pi times a radius of 1.5 now, divided by the period. Oh, no. Divided by 0.5. So we've increased our radius, but our period is staying the same. Does that mean our velocity, compared to our last problem, is our velocity going to increase or decrease? Are we going to go faster or slower now that we're further away from the center of rotation? We're going to go faster. It's just like whenever you're walking up the stairs and your friend makes the turn around the banister and you've got to walk faster to keep up with them because you have a further distance to travel now. So for this one, it's still 2 pi times r, which is 1.5, divided by 0.5. So our velocity is 18.85 meters per second. So that is our velocity. So far, exactly like the last problem, just the radius is now different. So our next part is to find the centripetal acceleration. Centripetal acceleration is the tangential velocity squared divided by the radius. We know our tangential velocity is 18.85, so we need to square that and divide by our radius, which is 1.5. Most people, if you're going to make a mistake on this step, one of two things happen. Either you forget to square, or you use the period as opposed to the radius. I'm not sure why, but that's just a common mistake that happens. So we take 18.85 squared divided by 1.5, and we get an acceleration of 236.87 meters per second squared. So any questions on that one? All right, so now to find the force, which I'm kind of running out of room on my screen. Force is equal to mass times acceleration, just like before, except now we're looking for centripetal force, so we use the centripetal acceleration. Just like when we were looking for the force of gravity, we would use the acceleration due to gravity, because it's a special kind of force. So I'm going to do this up here. So to find the force, you take the mass, which is 5, times the acceleration of 236.87, and we get a force of 1,184.35 newtons.